there were these standards, and a few of the standards in Common Core were identified with some of the standards there. It doesn't say anything more than that. Those few could be standards that were common to every set of standards in the world. So to say, as we were being asked to, they're internationally benchmarked, and have that phrase cleverly structured so that most of the audience would interpret it as benchmark against the top countries. That's not what it means. That was embarrassing to me. It was embarrassing. It was insulting. And I couldn't sign off on that. I couldn't sign off on the, that they were research-based. For example, the geometry that they added was based on a failed experiment in the old USSR in the late 1970s, where a geometry sequence was put together that looked amazingly like what is being asked for in Common Core, but it was restricted to the top achieving kids in the USSR. It didn't matter. Didn't matter. To do it right was so hard for even these kids that it lasted for about a year and a half, and it quickly went away. That's the only research for the geometry. And that's an indication of the quality of the research that is underlying Common Core. There's no way I could sign off. So, now let's look at another subject here. I mentioned that if you stop with Algebra 1, you have a 7% chance of getting a degree ever in any subject. Well, we now have a document in its final form that stops with a weak Algebra 2 course. Well, let's be generous and say it's a real Algebra 2 course, and let's ask again the question, what does the NCES data say about the probabilities of getting a college degree with just an Algebra 2 background? Well, it varied over time, but it kept dropping. So every 10 years, they examine and follow an entire class, and they get data every 10 years, and that was part of the data set that they were looking at, and I mean that was part of the data that they extracted from the data set and was available, and so it was declining significantly for reasons that were a little obscure, but the best estimate today is that between 31 and 33% of the kids who stopped with Algebra 2 would ever get a college degree in any subject. Well and good. I mean, that's better than 7. But, I mean, from my perspective, to say something is college ready would mean that, for me, that there's at least a 50% chance that a kid is going to get a college degree if the kid has the background that you're asking for. Okay? I mean, I think that's reasonable. 50% is reasonable. But this is only 33%. So it's a very weak definition of college readiness. Thank you. And still, it's better than Algebra 1, but boy, that's not saying all that much. And it turns out that more recently, the NCES actually gave me a piece of data that was allowed me to focus in on the same set. What is the probability that kids who intended to major in a STEM area, everybody knows what STEM is, right? No? Okay, science, technology, engineering, and mathematics. STEM areas, science, technology, engineering, and mathematics. So anybody who wants to major in those areas and maybe in a technical, a related area like operations research, computer science, so forth, that I will roughly call STEM. And so what is the probability that a high school graduate who has an Algebra 2 background and nothing more, who wants to major in STEM, what is the probability that that student will get a STEM degree? Anybody want to guess? Okay, go lower. 0, almost. 2. Right, 2. It's 2%, i.e. there's a 1 in 50 chance that such a student will ever get a STEM degree. Oh boy, but one of the 3 main pillars on which Common Core is based is strengthening the STEM pipeline. And gee whiz, there is no way I could see that this made any sense. But that's what we're stuck with. I mean, as Sandy pointed out, we can't change that document. It's copyrighted. And we, on validation, repeatedly asked for a mechanism for changing things. We knew there would be problems, and we wanted a mechanism so that you could produce new editions. And we never got a response. We never got one word of response from the people, the hidden group of people that were controlling what was going on. So we're really stuck with this. And we're stuck with that level. But anyway, let's return to this, to the question of college readiness. And let's say, as I told you, I don't think it's rational to have less than a 50% chance of succeeding in college be called college readiness. So you can go back to the data from the NCES and find out when does it happen that a student has a 50% or better chance of receiving a college degree of any kind, not just STEM, of any kind. And I'll tell you what the numbers are. That if you add in, instead of finishing with Algebra 2, you finish with trigonometry, then there's a 60% chance. There's a big jump. And that would be acceptable, but minimal. If you finished with pre-calculus, is higher. And if you finish with calculus, it's 86%. Now, that's really high enough. So you would probably achieve a satisfactory definition of college readiness and Common Core if you included at least trigonometry, and optimally, if you included an option of calculus, you'd have a very sensible situation. Thank you. All right. So we can look at the status quo and see across the country, because even national standards, we can see across the country, how many of our high schools across the country offer calculus? Okay, fair enough. But that's not a fine enough question. Let's refine it. Let's look at the top quintile economically among districts in the country, so the top 20% economically, the top 40%, the top 60%, the top 80%, and finally the lowest quintile. Let's compare the top quintile with the lowest quintile and look at what we get. 75%, nationwide, 75% of the colleges that are in the top quintile economically have a calculus course available. 40% have in the lowest quintile. As to regards trigonometry, which as we've seen is really kind of minimal, 85% have calculus in the highest quintile, and about 60%, which is pretty decent, but still pretty poor in a way, have trigonometry in the lowest quintile. So, and now, in the reality of Common Core, the situation is, of course, that neither one of these is required. There are no standards in Common Core at all that relate to these things. And in a minute, I'm going to quickly describe something that is highly non-obvious to people, that, the response when this is pointed out to schools and principals and superintendents and so forth is, oh, no problem, we'll add trig and we'll add calculus, we just make sure we'll do it, and we fix the only problem that you're pointing out. And we'll see that's actually not feasible. So, at any rate, so let's see. Yeah. Okay, so I guess I've said enough about that. Let me go on and I'll get to the feasibility issue now. So I have to tell you a little bit about mathematics and what's called scope and sequence in standards. The standards, you see, if you look at the standards for an 8th grade standard, maybe a standard that relates to and analyze in solving a simple a simple linear equation, then you want to look at what does it require that a student know from previous classes, and what's the reason that you might want to put this in at all? What in the higher classes and in real life, what is it that standard will be used to support? Okay, there's one thing, again, and this is essential because you have to remember that mathematics is entirely hierarchical. In mathematics, everything you do in 4th grade depends, or anything you do in 4th grade, depends on everything you did in 3rd grade and the quality of the learning that the kids has in 3rd grades of all those topics. If you don't know a topic, it is going to affect you in 4th grade. A 3rd grade topic will affect you in 4th grade. And the same with 8th grade. If you don't know all the topics from 7th grade, it will affect you in 8th grade. There will be topics that you will suddenly get lost in, and then in 9th grade, that area will be necessary for other topics. You'll get further behind, and so on and so forth. That's the idea of scope and sequence. And what you do when you actually analyze a set of standards in mathematics is you look at your top set of standards in the highest kind of courses that are there, and you say, okay, what are the topics in the earlier grades that these depend on? And they'd better be there. If they're not there, then the kids won't learn it. They're going to have to take this topic in grade 11, perhaps in trigonometry. They won't learn it because they don't have the foundation to learn it. And you get this phenomenon that fundamentally you cannot teach the topic of trigonometry if the standards that support it, that are necessary for the topics in trigonometry, are not present in the lower grades. So there's this notion of scope and sequence, and when you look at the same thing, you do that for trigonometry and you do that for calculus, then you get a notion of, quote unquote, in mathematics, missing standards. If the standards that support trigonometry and calculus are not there in the lower grades, then you have a problem. Now, what I did was to produce my own missing